everyone, welcome back to my YouTube channel. Myself Kushi.D from Sri Venkateswara College of Engineering. So today's topic would be local replication technologies in SAM. So moving on to the introduction, local replication technologies are used to create duplicate copies of data within the same storage system or on a different storage device within the same site. These technologies are essential for data protection, disaster recovery, and high availability. Local replication can be synchronous or asynchronous depending on the desired level of data consistency. So, local replication technologies are host-based and storage array-based. So in the host-based, we have logical volume manager, that is LVM, based on replication, that is LVM mirroring. Then we also have file system snapshot. In storage array-based, we have full volume mirroring, pointer-based full volume replication, pointer-based virtual replication. Local replication technologies involve duplicating data within the same storage system or across multiple storage systems within a single location. These technologies, such as mirroring and snapshotting, provide data redundancy, disaster recovery, and efficient backups without relying on external resources. Mirroring creates real-time copies of data on separate disks for high availability, while snapshots capture point-in-time copies for data recovery and backup purposes. By replicating data locally, organizations ensure data integrity, minimize downtime, and enhance overall system resilience within their infrastructure. So moving on to the next slide, we have benefits of local replication technologies. Improves data availability by ensuring that there are multiple copies of critical data within the same location. Enables rapid recovery from data loss or corruption by restoring data from the replicated copy. Helps in load balancing and improving performance by distributing data access across multiple copies. So here we have is reduced latency. Local replication technologies enable data replication within the same geographical area, minimizing latency compared to remote replication over long distances. Next we have is cost efficiency. By replicating data locally, organizations can avoid the expenses associated with transmitting data over long distances, such as network bandwidth and infrastructure costs. Next, we have is high availability. Local replication enhances data availability by creating redundant copies within the same data center or nearby locations, reducing the risk of downtime due to hardware failures or disasters. Next, improved performance. With data replicated locally, applications can access data more quickly, leading to improved performance and responsiveness, especially for latency-sensitive workloads. Next, we have is data sovereignty compliance. Local replications helps organizations comply with data sovereignty regulations by keeping data within specific geographic boundaries, ensuring adherence to local laws and regulations. Simplified management. Managing local replication technologies typically requires less complexity compared to remote replication setups, leading to simplifier configuration, monitoring, and maintenance processes. In this slide, we will be discussing about types of local replication technologies. So snapshot-based replication is one among it. So captures a point in time copy of data and allows for quick recovery to that specific point. Next we have is mirroring. Creates an exact duplicate of the data in real time on a separate storage device. Next is cloning. So creates a full copy of data that can be used for testing, development, or backup purposes. So snapshot-based replication is the first type, mirroring is the second type, and cloning is the third type. Moving on to the next slide. So we have a storage-based replication. So involves replication at the storage level where data is duplicated within the storage array itself, often utilizing features like snapshots or mirroring. Host-based replication. Replication managed by the host system where data is copied and synchronized between storage systems using software running on the most host servers. Next we have is array-based replication. Replication handled by the storage array which duplicates data between storage systems or arrays within the same infrastructure, often using technologies like synchronous or asynchronous replication. Next we have a snapshot replication. Captures a point-in-time copy of data, allowing for quick and efficient replication by only copying changes made since the snapshot was taken. Next, we have a synchronous replication. Ensures that data is replicated in real time or near real time, guaranteeing consistency between primary and replica storage systems but potentially introducing latency. Next we have is asynchronous replication. Copies data with some delay, allowing for more flexibility in replication timing and potentially reducing the impact on primary system performance, but may introduce data consistency challenges. So in this slide, we will be discussing about synchronous replication. In synchronous replication, data is written to the primary and replica storage simultaneously to ensure consistency. Provides zero data loss in event of failure but can impact performance due to the added latency. Typically used for critical applications where data consistency is paramount. So synchronous replication ensures that data is mirrored across multiple locations in real time, providing immediate consistency between primary and replica data. This method guarantees that every write operation is applied to both primary and secondary storage simultaneously, ensuring data integrity and minimizing the risk of data loss. However, it can introduce latency as the primary system waits for acknowledgement from the replicas before confirming a write operation. This makes synchronous replication suitable for scenarios where data consistency is paramount, such as critical databases or financial transactions. Despite its reliability, synchronous replication may impact overall system performance due to increased latency and dependency on network stability. So moving on to the next slide, we have is asynchronous replication. So in asynchronous replication, data is written to primary storage first and then copied to the replica storage at a later time. So this is the difference between synchronous and asynchronous. Offers better performance compared to synchronous replication but may result in some data loss in case of failure. Often used for less critical applications where minor data loss is acceptable. So this is the image that depicts asynchronous replication. So here we have is asynchronous replication copies data with delay. Data is sent from a source to a target in a separate way. The source continues its operation without wait, while the target receives data at a different rate. This method sacrifices consistency for speed with potential data loss if systems don't heed. Asynchronous replication suits non-critical data at its best. So for real-time consistency, it's not ideal quest. So in this slide, we will be talking about implementation consideration. So consider the recovery point objective, that is RPO, and recovery time objective, that is RTO, while when choosing a replication technology. Evaluate the impact of replication on performance, bandwidth, and storage system. Test the replication process regularly to ensure data integrity and recoverability. So here we will be talking about best practices for local replication. Implement a combination of synchronous and asynchronous replication based on the criticality of the data. Monitor replication process regularly to detect any issues or failures early. Ensure that replicated data is encrypted to maintain data security and compliance. So, challenges of local replication. Replication can consume significant storage and network resources, leading to increased costs. Managing and coordinating multiple copies of data can be complex and require careful planning. Data consistency and integrity must be maintained across all replicas to avoid data corruption. So first one we have is limited scalability. Second one we have is single point of failure. Third one we have is increased resource utilization. Fourth one we have is geographic limitations. Fifth one is complex management. And sixth one is compliance and governance challenges. So moving on to the next slide, we'll be discussing about some case studies of local replication technologies. Company implemented synchronous replication for its mission-critical database, ensuring zero data loss in case of a disaster. Company B uses asynchronous replication for its file servers, balancing performance and data protection effectively. So we have two companies, that is company A and company B. So one is using synchronous and another is using asynchronous. So there is company C, which leverages snapshot-based replication for its virtualized environment, enabling quick recovery and testing capabilities. So, as we discussed previously, so some of the local replication technologies are these. So, I would like to give the conclusion as local replication technologies offer a crucial solution for data redundancy and disaster recovery at a local level. By duplicating data within the same infrastructure, they provide swift access to backups and minimize downtime in case of failures. Additionally, these technologies often integrate seamlessly with existing systems, reducing complexity and cost. However, reliance solely on local replication may leave data vulnerable to site-wide disasters, emphasizing the importance of combining it with off-site or cloud-based replication for comprehensive protection. In summary, while local replication technologies enhance data resilience and accessibility, a comprehensive disaster recovery strategy should incorporate multiple layers of redundancy for optimal security and continuity. Thank you for watching my video. Please do like and share it with your friends. Thank you.